Let's take a look at some compression utilities that allow us to move data seamlessly across the wire. They include tar, gzip, bzip version 2, as well as zip. So in fact, tar is not a compression utility, and it's rather a utility that allows you to roll directory structures into a single file for easy transport, perhaps across your intranet or the internet. The other tools, gzip, bzip version 2, and zip, are compression utilities that are quite commonly used in saving bandwidth when moving data across the net. So with that said, let's launch gedit, a recent invocation of it, to bring our notes up. And we tend to cover these tools frequently because you'll find content online that are available for NIX-based systems represented in this particular format. So we'll call this compression utilities, despite the fact that tar is not a compression utility but works in conjunction with compression utilities. So features include reduced footprint of content and the ability to compartmentalize or to roll many files and or directories into one file for easy transport. So we use tar in conjunction with various utilities. Now let's begin with the compression utilities. So we'll compress content, realizing the reduced footprint, and then roll that content into easy to transport files. So our first task will be to explore the tar utility. So we'll be looking at tar. Tar is available on virtually all NIX-based systems. In fact, let's look at gzip first because we want to actually compress first before we roll. So let's gzip first. So gzip is available on most NIX-based systems, including Solaris and BSD and others. Gzip will allow us to compress content to a reasonable size for transport. So let's find some content to compress. We'll navigate into temp and we'll create the content there. If it doesn't exist, let's make directory temp, followed by a change into temp. By the way, this is a way to execute commands using double ampersands within a bash shell if the previous command executed successfully. So if make directory temp is successful, then a cd into temp will execute. So now we're in temp. So we need some content. Well, we can create a file and compress it. So this is where the sequence command can be useful, or dd, to generate a number of bytes. But for example, supposing we wanted to create a file with 1 million entries. Using output redirection, we'll call this file 1million.txt, which is what we normally create. Now this will quickly create a file, echo the exit status, and then stat 1million.txt that is roughly 6.8 megs. And to transmit this file across the internet is not a big deal with today's broadband connected environment. However, supposing you could reduce this footprint to something quite smaller, let's say a third of the size, then it makes transmission much, much quicker as a result. So that's the whole purpose of using compression. So to compress this file, we use gzip with the create option. So an option on this would be gzip c, and we'll take 1 million. We often use a file name 10million.txt. And by default, gzip, like bzip version 2, defaults to or presents its output on standard out. So if you don't output redirect the content, let's just go ahead and do it without it, you'll see that gzip will simply dump the compressed content to standard out, which is not what you want. So for example, gzip create 1 million text without output redirection simply enumerates the garbled binary on our screen, which is of no use to us, which is why we need output redirection. Sometimes this will corrupt the shell, and in which case you can use another built-in command, reset, to reset the buffer. In our case it didn't, but nonetheless it helps to know that you can. If you're operating on a NIX-based shell and you see that it's been corrupted, then use the reset command to help you out. Yet another Unix-based command. In fact, let's just add this to the list of commands before we move on. So reset resets a garbled terminal. So with that said, gzip create dumps a standard out, so we redirect the output into a file such as 1million.text.gz. So this will create a compressed version in a file representation of the source file 1million.txt, and then we can compare and contrast the file sizes. When we're finished this, we'll stat it. So let's go ahead and paste this in and echo the exostatus. Now let's stat 1million.txt. In fact, let's stat both of the files. So we can see the original file is about 6.8 megs, and the new file, or the compressed file, is roughly 2 megs. So it's roughly a third. And if we look at it in human readable format, both files, you'll see that one is 2.1, the other is 6.6, so it's roughly a third. So 2/3 have been shaved. That's a big difference, because when copying this content online, it will significantly decrease the amount of time necessary to move the content across the wire. Now, a file against both of these items will reveal that one is an ASCII text file and the other is a compressed file. So if you use a pager such as less, for example, to interact with 1million.txt, which is the ASCII text source file, it enumerates all the lines 1 through 1 million. If you use less against 1million.text.gz, it enumerates the binary. But we can always get past this by using commands that have built-in decompression support of gzip, for example, such as zcat. So for example, zcat 1million.text.gz, piping the output to less so we can see the output one page full at a time, does the trick for us. So let's just note, zcat and the target file 1million.text.gz auto decompresses the gzip compressed file on the fly, and it sends the output to standard out, so to stdout, which means if you use output redirection, you could use zcat to recreate the original file. So for example, zcat 1million.text.gz dumps the standard out all the way through 1 million. However, if we break the process with Control-C and then re-zcat, notice the exostatus is no longer 0, sending the output using output redirection, for example, to 1million.text, let's call this one 2, and then echo the exostatus, which is now clean. And now we've got a new file with a suffix of 2, which is identical in size to the source file, 1million.text. So you can use output redirection with zcat to decompress, but you may also use gzip or gunzip to decompress the file. So let's continue with some additional ways in which you may use this. So we know how to create a gzip compressed file out of a single file. To decompress, we can use either gzip with the decompression option or gunzip, which is really just a reference to gzip with the decompression option. So gunzip 1million.text.gz will decompress the file. So let's go ahead and try this out. That'll be gunzip 1million.text.gz. Now notice, it attempts by default to overwrite the source file, 1million.text. We'll tell it no. That way it doesn't overwrite the source file, 1million.text. Now what happens if we indicated that it should? Let's go ahead and indicate yes, echo the exostatus, which is clean, and an LSL. Notice that it's removed the compressed file. So when you use gunzip, by default, it attempts to overwrite the source file and remove or clean up the compressed file. So attempts to overwrite source file if it doesn't exist, and removes compressed file when the process is completed. So that's the behavior of gunzip. Now let's do a which gunzip to see where it is. It's in bin, and a which of gzip. They're both in bin. So let's LSL bin gzip as well as bin gunzip, and we see that both of these items are in bin and they're symlinked, and they're both available for us to compress, decompress. Notice the significant size differential in gunzip because it's really a reference to gzip. If we run gzip with the help option, we'll see that the D option is the decompress option. This is basically how gunzip calls gzip. Now if we do a file against bin gunzip, we'll see that it's actually a shell script. So that means we can use a pager such as less, or since it's only 63 bytes, cat to enumerate the contents. Now, by the way, with command substitution, we can use backticks or the alternate notation, which is $ open and close parentheses, to include or expose or expand the full path of a given file. So supposing we don't remember where gunzip is located, we can simply pass in, using command substitution, the which of gunzip, and this will put the path in for us. So notice, which gunzip, meaning we don't remember where it is in the path, so the command substitution executes which gunzip, which really expands to the following: which gunzip /bin /gunzip, which cat takes in as an argument. So really what happens when gunzip is called is the execution of gzip with the D option to decompress, which then decompresses whatever argument is supplied on the command line. So that is why it is significantly smaller than gzip. So gzip-d will also perform likewise. So gzip d file name 1million.txt.gz. This is identical to gunzip and the same file name 1million.txt.gz. So just have that as an additional thing to track with respect to how gunzip works. Now you can force the overwrite of the output file so that you're not prompted by indicating the F option. And let's take a look at our content. Now we currently don't have a compressed file, so let's compress our file. We'll gzip create 1milliontext.gz followed by an LSL. And now we have the compressed version of it. And then if we gzip d 1milliontext.gz, this will, to standard out, dump the contents of 1million.txt by default, or in this case to the output redirected file. So it overwrites the file automatically as opposed to going to standard out. So let's go ahead and recreate that file. And there it is. So gzip-d does the same thing. It dumps the content. In this case, it dumps it to file. And gunzip, let's go ahead and gunzip 1milliontext.gz. This does the same thing, which is to write it to file. We'll tell it not to. So that's a little bit about gzip. It significantly reduces the size of the source file for transmission. Now, some other tools are of interest to us. For example, bzip2. bzip2 works similarly to, or behaves similarly to gzip, but often achieves better compression. So that's the next tool, bzip2. So oftentimes when you find content online, you'll see that it terminates with a suffix of .bz2, perhaps preceded with .tar, so tar.bz2 or something of the sorts. You'll often see with gzip, tgz, for example, as a suffix, or tar.gz. So when you see those files, you can try to decompress them using bzip2 or gzip. You may also execute file against them to determine with a high degree of certainty the type of the file, so that you know which compression utility to use to interact with the file. So to compress content, it's a similar syntax. bzip2 is called with the create option, let's say for 1million.txt, and then we send the output to a file such as 1million.txt and a typical suffix of bz2. This is commonly used. Now the behavior, standard behavior of bzip2 when output redirection is not used is similar to gzip. So let's create this file, gzip, or bzip2 that is. So that's going to be bzip2 create 1million.txt, and this will, in its standard form, try to, but it throws an error because there's a condition in there to dump the standard out and says it won't write the compress because it runs a risk of garbling the terminal. So bzip2 has that one caveat built in whereby it prevents your terminal from becoming garbled by not attempting to write the standard out. But that is the normal behavior, so there's a hook in there. So to send to a file with a similar target, we simply include 1milliontext.bz2, and this will create the file. Let's echo the exit status to make sure that it's clean. And now we see the bzip version 2 file. Notice that the bzip file is significantly smaller than the gzip file, which is why it's often advantageous to use bzip2 compression. It's 1.2 megs. This is a significant difference over the gzip comparable file with respect to moving data across the internet. So now we have a bzip version 2 file. Let's do a file star against both of these items. One is bzip2 compressed, the other is gzip compressed. You cannot use gzip, for example, gzip with the decompression option to decompress 1million.txt.bz2, for example. Let's try that out. It doesn't know the type, it's not familiar with it, nor does it understand the compression algorithm, so you wouldn't expect it to work. Now, along with bzip2 compression, we can bunzip 2 to decompress. So bunzip2, the name of the file, such as 1million.txt bz2, will decompress the file. And let's try this out. Let's just get this into the buffer so we don't have to retype it. And notice the output file already exists because the normal behavior is to overwrite the file. So bzip, or bunzip2 that is, with the help option, shows you the options that are available. You can force an output to stand it out, for example. So bunzip2, and that dumps the standard out. And then, of course, you could output to a new file, such as 1million.txt2, for example. And now that creates a new version of a file. Notice that the byte size of 1million.txt2 is the same as the other file. So you never lose the original file sizes if the original compression succeeded. Now, just like with gzip, the zcat provision, which allows us on the fly to cat the compress file to stand it out, bzip version 2 has its counterpart, and it is bzcat. So bzcat 1million.txt bz2 on the fly, so it's like zcat, auto decompresses the bzip version 2 compressed content on the fly, of course. Why is this important? In particular with log files that may use this format. For example, files that have been compressed using either of the algorithms via log rotate that you need to interact with, for example. So on the fly, dumps it to stand it out, and of course we could use output redirection to recreate the original file, which bzcat reveals that it's a utility that's available for everyone, which bunzip2, it's in bin, ls bin. bunzip2 shows that it's 26,356 bytes, and bzip2 is the same size, which begs the question, are they the same file just being called with two different options? Well, an ls option that we didn't look at is the I option, which reveals inodes associated with files. So when you confirm the inodes of various files, for example, you can tell whether or not they're the same file. So this tells us that they're the same file because they wear the same inode. Let's copy this block and paste it in, just as an FYI. Whereas in the case of gzip and gunzip, they're different files. Gunzip is simply a shell script which calls gzip with a particular option, whereas bzip version 2 and bunzip, let's just double check, make sure that we have the right item here, and let's do an lsli bzip2 and bunzip2, and indeed, so this is the proper output that we wanted, and let's just make sure that we have them on both lines independently. So let's copy this entire block and paste it into our notes. But indeed, they are the same file, but when the program is called as bzip2, it knows that it is to compress or to default to compressing the content, and as bunzip2 to default to decompressing the content. So let's just note both files reference the same inode. which means they are the same file being called in different manners, which is why they behave differently based on how they're called. So bunzip, bzip version 2, bzip often achieves, let's just note, often achieves superior compression ratio to both gzip and zip. That leads us to traditional zip, which is definitely available across platforms. But with WinZip and unrar, rar across platforms, all these formatted types are supported nonetheless. But nonetheless, it helps to know in the event that you receive a file with any of the suffixes that pertain to these particular programs, such as zip, bzip2, or gzip. So zip, unzip. So zip and unzip. Traditional zip and unzip, will create a zip compressed archive of a file or a path as specified. The syntax is slightly different, so if you'd like to back up or archive, let's say 1million.txt, you first specify the target file name as opposed to the source. So it'll be zip 1million.txt.zip, for example, followed by the file name 1million.txt. This is one way in which zip differs. The invocation of zip differs from both bzip version 2 and gzip. So let's try to create the content, and it's not copied into memory. Our Control-Shift-C isn't being interpolated correctly unless we copy it manually. Now let's do a which zip. It's actually not installed, that's why it doesn't come up. Unzip is not there either, and unzip is actually there, but zip isn't. So let's go ahead and su in and try to do an aptitude search for zip to see if we can quickly bring zip into the fold. Notice that it's listed, but it's not installed. And this is perhaps because most of the content that you'll find for NIX-based systems are compressed using gzip or bzip version 2. And gzip will also read zip formatted content. So let's aptitude install this time zip, although we've yet to look at application installation. This will quickly give us zip so that we can use it. And then let's rerun it. We'll drop our shell, and now we'll have the content. Another neat thing about zip is that it reflects on the fly the percentage of the content that was saved. So that means our target file should be about 2/3 smaller than the source file. So the target file is 2.1 megs, which is basically the same as the gzip formatted file, and the source file is 6.6 megs. So roughly 2/3 have been saved. But in the case of bzip version 2, it's roughly a sixth saving, 5/6, as opposed to 2/3, which is a greater saving. So in this case, bzip version 2 worked out to be better for us. So there's our zip file. Now, insofar as enumerating the contents of this file, we can use zcat. The same zcat from our gzip study will interact with zip archived items. So zcat 1million.txt zip, for example, works appropriately. It understands the zip format. So zcat 1million.txt zip enumerates the content of the file, as it does with gzip. To unzip the file, use unzip. So unzip and the name of the file. In this case, 1million.txt.zip. And this decompresses the content. And as we saw, unzip was installed independently of zip. So let's lsl user bin zip. And unzip, we could have done a star zip. So here, and let's turn on the inode feature. So here we see that zip has an inode of 471457, and unzip is 204352. This tells us that they're different files. And as a consequence, let's take a look at our content. Let's try to unzip 1million.txt.zip. And this will attempt to replace the original source file. So we'll tell it not to. Unzip also supports the ability to enumerate the contents of the file. So you can take a peek without decompressing the content. 1milliontext.zip, and it shows you what's contained within the archive. Zip also supports backing up directory trees. So this is the temp tree. So if we navigate a level up and zip temp.zip, for example, indicating the temp hierarchy, this will archive the temp directory tree. Let's take a look at our temp.zip structure, and this should give us a sense momentarily. And we did indicate either the R option to indicate recursive or star asterisk to include the items recursively. So two ways to do it. So now when we LSL temp.zip, we'll see that it's larger than 0 bytes or 160 bytes. And an unzip L temp.zip reveals the content, including the top level directory container. So what happened in the original case was that it backed up the top level container but not the items recursively. Zip with the R option will compress recursively. So zip R temp.zip, temp, for example, backs up recursively. The top level container is just a directory entry, so it is empty, and all of the items contained within LSLTRH or stat of temp.zip now reveals that it is 8.3 megs, which includes the full content. And of course, the other utilities, such as gzip, bzip version 2, will behave similarly, for example, with the R option for gzip. So let's go ahead and gzip recursively. In this case, we're looking to archive the temp directory. So we want temp, and this will, of course, when we create the archive, dump the standard out, the whole archive, so we can send it into temp.gz, for example. And then this will create an archive for us. Let's lsltrh temp star. This will enumerate the contents of the directory as well. If you have a directory named something that matches what you pass to ls, its contents will be enumerated as well. So notice temp.gz is 6 megs. Gzip also supports a list option. So if we gzip l the temp.gz file, we see what's contained, which includes the directory temp with the percentage of the compression and so on. And similarly, bzcat with the help option returns various options, which allows us to create these sorts of archives. However, tar is more apropos for this particular application in terms of being able to back up directory trees, indicate which items are to be excluded from the list and so on, it's a much more powerful tool to indicate the items within a directory hierarchy that are to be archived. And that is why you'll often see files and applications distributed in a tar.some compression form. So that's why it's important to know, and we always lump it in with compression utilities whenever we study it. So tar, for example. Now we'll be using tar with gzip and bzip2. So one example invocation of tar with gzip, for example, or with no compression, is as follows. Tar, create an archive, verbosely, force a creation, and you specify, just like with the zip, the target first. So temp.tar, which is the name of a file that we'd like to archive, followed by the source, which is temp /. This will create an archive sans compression. That means whatever the size of the archive amounts to is what the file will represent, plus some additional overhead, of course. So let's create this archive. Now let's lsltrh temp, and we'll see that temp.tar is 25 megs, so no compression. In fact, if we file temp tar, you'll see that it's just a tar archive with no compression. So to effect compression on this particular item, we just turn on a desirable option. So CV F are still used, but if you'd like to use, let's say, gzip compression, enable the Z option. Followed by the same syntax, temp.tar, which is the target file, and give it a suffix that you're likely to or commonly interacted with online, either tar.gz or tgz, for example. So tar.gz, temp /. So this applies compression to the archive. And in particular, it applies gzip compression to the archive, which makes it all the difference. So let's find the tar invocation, turn on the Z option, temp.tar.gz, and this will back up the archive for us. So it'll roll it into a tarball, and then it will compress it. So there's temp.tar, which is 25 megs, and here's temp.tar.gz, which is 6.5 megs. Let's turn on the H option. Human readable, 6.3, 25. So it's roughly a fourth of the uncompressed file. And similarly, if you turn on compression with bzip version 2, expect to realize better compression as a result, since we've already shown that bzip works out better. But with respect to bzip compression, tar will respond to that format when you reference the J option, and the suffix will be bz2. The suffixes are not important in Linux-based, NIX-based systems, but they help us visually since it is what is considered standard operating procedure to use some sort of suffix. So let's create this archive, and there we have the whole thing. So we'll just retrofit the recent invocation. So this will become tar bz2, and this will become J to indicate that we want bzip version 2 compression. And then let's re-LSL when this is complete the temp tar star items with human readable format turn on. Notice that we're able to, with bash on GNU Linux, separate the command line options for ls around the item that's to be operated on. This doesn't work on all distributions and all flavors of Linux and Unix, so you have to try it accordingly. If it's GNU Linux with GNU bash, then it'll work, but if it's some other flavor of, let's say, the bash shell or corn shell, let's say on Mac OS X or other Unix distros, it will not work unless it's been retrofitted. So here's a temp tar bz2 file, and notice it's considerably smaller than the temp tar gz file. So this is more apropos for transmission across the wire. And of course, once a file has been tarballed, you can interact with it using a number of options. You can extract its contents wherever you'd like using tar. So let's first look at the contents of the file using tar with the appropriate options. So if you'd like to list the archive's contents, a number of things come to mind. Since it's a compressed archive, we can use the T option. So tar with T VJF temp tar bz2. And this will enumerate the contents of the file for us. And it doesn't extract it, by the way, it just enumerates it. And if we'd like to see the gzip version, then change J to Z and the bz2 to gz, and it enumerates it likewise. And to extract, just use the X option. So tar tvjf temp tar bz2 lists the contents of the tarball /bzip2 archive. And similarly, tar tvzf temp.tar.gz lists the contents of the tarball gzip archive. And to extract, of course, you simply use the X option. So let's just pick one to extract. Tar X. Let's go with the gzip version. VF temp tar gz extracts the contents of the archive. And again, tar is far more powerful than we're showing. For example, you can indicate which content of your tarball image to extract in various places. Let's make a directory temp2, for example. And then if that works out, we'll change into temp2. And then we'll tar, let's paste this, from our root directory, our home directory, that is, temp tar gz. So this will extract the hierarchy here, creating a subdirectory of temp, preserving timestamps, and there's the content. So the idea is that there are a number of tools that allow us to compress and decompress content. In the world of Linux, you'll largely find content compressed with gzip or bzip version 2 and rolled into an archive, a single file which contains directory branches from one or more directories, which tar supports, and presented as tar-gzs, tar-bz2s, or tgz or tbz2, for example, suffixes. And with that information, you can then move information efficiently across networks. And it makes it even easier to secure the files. For example, supposing you needed to publish a number of different directories. Let's say you have 10 different directories that you'd like to roll into an archive, then sign and encrypt using GPG, and then share with the world. As opposed to signing and encrypting all of the content across all of the directories, you use tar to amalgamate all the content into one hierarchy, sign that particular tarball, and then encrypt it accordingly. You'd simply just tell tar, so for example, from our home directory, if we wanted to create an archive that consists of, let's say, in this case we're going to go with bzip version 2 compression. So supposing we wanted to include, or we'll label this temp underscore temp2.tar.bz2. So this archive will consist of temp as well as temp2. And both directory trees will be included as a consequence. And supposing we wanted to stick documents in for good measure. So now it walks through temp, through each of the arguments presented on the command line, then temp2, then documents, and then our new archive will contain everything. Well, documents turns out to be empty, but the directory entry has been maintained. So let's lsltrh temp underscore. So it's 7 megs. Let's tar tvjf temp underscore to enumerate the content. So if we extracted the contents of this file, it would reconstruct a hierarchy which resembles the following, wherever we intend to extract it. You could, of course, then extract just components of the directory tree, such as tar x, in this case jvf, the name of the file, and the directories that are of interest. So for example, let's navigate into temp2, and supposing this is where we wanted to set up shop. We'll remove rf this tree just to clean things up. So we could tar xjvf from our home directory using .. or tilde to indicate our home directory, temp underscore, that's the file, and then just the temp2 hierarchy, for example, or a specific file from the temp2 hierarchy. Either or would allow us to do it. This will give us the entire hierarchy. Let's remove rf temp2. Supposing we wanted just, say, temp2 and temp 1,000,000.text.zip for the zip file, for example. This will extract just that file, but of course it recreates the hierarchy. So temp2, temp, and then 1,000,000.text.zip. So those are ways in which you may extract specific content. So for example, tar x jvf temp tar, or this was temp2 tar.bz2 followed by specific directories, temp2, for example. You can specify one or more, extracts solely the temp2 directory hierarchy from the archive, making tar rather powerful. So let's move on to some other content of interest.